Picture a single moment frozen in time. A wine glass falling from a table suspended in mid-air just before it hits the ground. In this perfect instant, the laws of physics tell us something extraordinary. Every equation that governs motion, every force at play, every molecular interaction happening in that glass works exactly the same, whether time moves forward or backward. The mathematics don't care which direction the clock ticks. Yet here's what will blow your mind. That glass will never spontaneously leap back onto the table. The wine will never flow upward to refill itself. The scattered fragments will never reassemble into perfect crystal. Something profound prevents the universe from rewinding. And tonight we're going to uncover the hidden force that makes time's arrow fly in only one direction. I'm about to reveal why entropy isn't just some abstract concept your physics teacher mumbled about. It's the most fundamental law governing reality itself. The cosmic rule that ensures your coffee always gets cold, your room always gets messy, and why you can never truly go back to yesterday. This isn't just science. This is the deepest truth about existence hidden in plain sight. Before we dive into the revolutionary implications, hit that subscribe button because what I'm about to show you will change how you see every moment of your life. We're going to explore why the universe operates like a cosmic one-way street, and by the end you'll understand the profound reason why nothing can ever truly return to the way it was. Now prepare yourselves. We begin. Let me start with something that should terrify and fascinate you in equal measure. Right now, as you listen to these words, trillions of invisible processes are conspiring to ensure that this exact moment will never happen again. Not just the obvious things like your thoughts or the position of clouds outside. I'm talking about something far more fundamental. Every breath you take increases the total disorder in the universe. Every heartbeat, every blink of your eyes, the very act of existing pushes reality further away from any possibility of return. You are personally actively making time irreversible with every second that passes. This is entropy in action, and it's about to get much stranger. Scientists have known for over a century that the fundamental equations of physics are time-symmetric. Newton's laws of motion, which describe the elegant dance of planets, and the trajectory of a thrown ball work the same, whether you run them forward or backward. If you were to watch a film of a collision between two billiard balls, you wouldn't be able to tell if the film was playing in reverse. The physics would look equally valid. Einstein's theory of general relativity, our best description of gravity, treats past and future as equivalent coordinates on the four-dimensional map of spacetime. Even the bizarre rules of quantum mechanics governing the subatomic world show a perfect symmetry in time's direction at the most basic level. The mathematical universe, the pristine world of equations that underpins all of physical reality, doesn't distinguish between yesterday and tomorrow, but reality clearly does. We age never getting younger. Our bodies are chronicles of one-way change, scars that never fully fade, cells that divide a finite number of times. Heat flows from hot to cold, never the reverse. An ice cube in a warm drink melts, but you will never see a lukewarm drink spontaneously separate into ice and hot liquid. Information gets lost, never spontaneously recovered. A book burned to ash cannot be unburned. The universe expands its galaxies, rushing away from each other, never contracting back to its starting point. Something creates an arrow of time that points relentlessly toward increasing disorder. That something is entropy, and understanding it requires us to think about reality in a completely different way. Imagine you have a box divided in half by a removable barrier. On one side, you place 100 red marbles. On the other side, 100 blue marbles. This is a state of perfect order, a highly organized low-entropy configuration. When you remove the barrier, what happens? If you gently shake the box, the marbles begin to mix. Red and blue spread throughout the entire box until they're thoroughly jumbled together into a uniform purple haze. This is a state of high disorder, a high entropy configuration. Now, here's the critical question. How likely is it that if you keep shaking, those marbles will spontaneously separate back into their original red and blue halves? The mathematics are brutal. The probability is approximately 1 in 10, followed by 60 zeros. That's a number so vanishingly small, it makes the chances of winning the lottery every day for 1,000,000 years look practically guaranteed. It is so improbable that if every person on Earth shook a box of marbles every second for the entire age of the universe, we would still not expect to see this event happen even once. This is why entropy always increases. Not because the laws of physics forbid the marbles from separating, they absolutely allow it. There is a sequence of bounces and collisions that would perfectly return every marble to its original side. The problem is probability. There are vastly more ways for the marbles to be mixed than separated. For every one perfectly ordered state, there are googles upon googles of disordered states. The universe, through its constant motion and interaction, simply explores the space of all possible arrangements, and it is overwhelmingly more likely to land in a state of disorder. Disorder is statistically inevitable, but marbles are child's play compared to what's actually happening in real matter. Every object around you, from a drop of water to a grain of sand, contains approximately 10 to the power of 23 molecules. That's more molecules in a single gram of water than there are stars in the observable universe. Each of these molecules is constantly moving, vibrating, colliding with its neighbors billions of times per second. The number of possible arrangements these molecules can take is literally beyond human comprehension. It is a number larger than the number of marbles you could pack into the entire cosmos. When you heat a cup of coffee, you're adding energy that makes those water molecules move faster and more chaotically. When the coffee cools, that energy spreads into the surrounding air, increasing the random motion of the nitrogen and oxygen molecules in the room. The total energy remains exactly the same, a perfect illustration of the first law of thermodynamics, the conservation of energy. But the energy becomes more evenly distributed, more disordered, more useless. This is why hot coffee always becomes cold coffee, never the reverse. The energy can't spontaneously concentrate itself back into the liquid. The probability of trillions of air molecules conspiring to transfer their kinetic energy in just the right way to the water molecules is so astronomically small that it would never happen even if you waited longer than the current age of the universe. The truly mind-bending part is that this applies to everything. Every process, every change, every moment of existence increases the total entropy of the universe. We are riding a one-way slide toward maximum disorder, and there's no way to climb back up. But entropy reveals something even more profound about the nature of time itself. Consider this thought experiment. You're watching a movie of smoke rising from a cigarette. Wispy tendrils curl upward, driven by the heat, and disperse into the surrounding air until they become invisible. The complex ordered pattern of the smoke plume dissolves into the random disordered motion of individual molecules mixed with the air. Now I play the same movie backward. The smoke flows in reverse. Invisible scattered molecules from all corners of the room converge, forming dense tendrils that somehow reconstruct themselves into the original shape of the plume, flowing backward and downward into the cigarette. Your brain immediately recognizes something wrong with the reversed version. It feels impossible, magical, a violation of nature, not because it violates any fundamental laws of motion or energy conservation. The individual molecules are following perfectly valid physical trajectories in both directions. You know it's wrong because it violates the second law of thermodynamics. Entropy is decreasing in the reversed version, and your intuition, honed by a lifetime of experience in a thermodynamic universe, tells you this is impossible. This is how you actually distinguish past from future, not by consulting a clock or a calendar, but by observing the direction of increasing entropy. The arrow of time is not a fundamental property of physics itself. It is an emergent property built into the fabric of reality through the statistical inevitability of disorder. Here's where it gets really strange. If entropy always increases, if the universe is always moving from a more ordered state to a more disordered one, then it must have started in a state of incredible order. How did the universe begin in such a low entropy state in the first place? The Big Bang, the moment of cosmic creation 13.8 billion years ago, began with matter and energy in an incredibly organized configuration. All the hydrogen and helium atoms were distributed with almost perfect uniformity. Gravity hadn't yet had time to clump matter into the complex structures of stars and galaxies. The cosmic microwave background radiation, the afterglow of that primordial fire, was nearly perfectly uniform in temperature across the entire sky. It had variations of only 1 part in 100,000. This initial state was a configuration of mind-bogglingly low entropy, a state of perfect cosmic smoothness. Since then, gravity has been pulling matter together into increasingly complex structures. Stars formed, creating heavy elements through the violent alchemy of nuclear fusion. Planets coalesced from the cosmic dust and debris orbiting those new suns. On at least one of these planets, chemistry became complex enough to create self-replicating molecules that we call life. Locally, in our corner of the cosmos, order has increased dramatically. But this apparent contradiction dissolves when you consider the bigger picture. Every star that formed, every galaxy that coalesced, did so by radiating enormous amounts of heat and light into the cold, empty space around it. Every fusion reaction that forged a carbon atom in a stellar core scattered energy across the cosmos. The formation of complex structures always releases more disorder into the universe than the order they create. The universe as a whole continues its relentless march toward maximum entropy. The sun that powers all life on Earth is actually a massive entropy generator. It is a testament to the creative power of destruction. It takes highly organized nuclear fuel, hydrogen, and converts it into less organized helium, releasing a torrent of scattered heat and light in the process. We on Earth capture a tiny fraction of that entropic exhaust and use it to build our temporary islands of complexity. In roughly 5 billion years, the sun will exhaust that fuel and begin its final transformation. It will swell into a red giant that will engulf Mercury and Venus, and perhaps Earth, before collapsing into a white dwarf. Then, over trillions of years, it will cool to a cold, dark cinder, a crystallized black dwarf floating silently through space. This is the ultimate fate, awaiting everything. Stars will burn out. Galaxies will fly apart, their constituent stars drifting into the intergalactic void. Black holes will slowly evaporate through Hawking radiation, a process that takes googles of years but is just as inevitable as the setting sunday. Even protons, the very building blocks of atomic matter, might decay given enough time. The universe is heading toward a state called heat death, where all energy is evenly distributed at a temperature just fractions of a degree above absolute zero. In this final state, nothing interesting can ever happen again. The cosmic clock will have wound down completely. But before you get too depressed about the cosmic endgame, consider this remarkable fact. You exist in the middle of this process. You are a temporary, incredibly improbable organization of matter that arose during the universe's journey from perfect order to perfect disorder. Your consciousness, your thoughts, your ability to contemplate entropy itself represents one of the most complex arrangements of atoms that has ever existed. The very fact that you can understand these concepts means the universe has become sophisticated enough to study itself. Through your brain, cosmic matter has achieved self-awareness. That's not just poetic language, that's literal truth. The calcium in your bones was forged in the nuclear furnaces of dying stars that exploded billions of years ago. The iron in your blood, which carries the oxygen that fuels your thoughts, was scattered across interstellar space by supernova explosions. The carbon in your DNA, the backbone of life itself, was created when the universe was young and stars were first learning to shine. You are made of stardust that has organized itself into a pattern capable of contemplating the deepest laws of reality. In a cosmos destined for heat death, you represent a brief, brilliant flame of consciousness burning against the darkness. This brings us to one of the most profound questions in all of science. If entropy always increases and the universe is becoming more disordered, how do we explain the existence of life, consciousness, and intelligence? How do highly organized systems like brains and civilizations arise in a universe supposedly running downhill toward chaos? The answer lies in understanding what entropy really measures. It's not just disorder in the everyday sense of a messy room. Entropy measures the number of microscopic ways a system can be arranged while maintaining the same macroscopic properties. A gas at a uniform temperature has high entropy because there are countless ways to arrange the individual molecules while keeping the overall temperature constant. A perfectly ordered crystal has very low entropy because there is only one way to arrange the atoms to form that perfect lattice. Living systems maintain their complex organization by constantly consuming energy and exporting entropy to their surroundings. Your body is an open system, not a closed one. It takes in highly organized chemical fuel like glucose from the food you eat and uses it to power the intricate machinery of your cells. In the process, it converts that organized energy into motion heat and waste products like carbon dioxide and water. The total entropy of your body, plus its environment, always increases, even though your body itself remains remarkably well organized for a time. This is why all life requires a constant input of energy. Plants capture the low entropy energy of sunlight. Animals consume other organisms to steal their organized chemical energy. We are all participants in a vast network of energy flows that temporarily create islands of order in the ocean of cosmic disorder. But even this explanation raises deeper questions about the relationship between consciousness and entropy. Your brain doesn't just process energy, it processes information. Every thought, every memory, every decision involves the manipulation of information patterns encoded in the intricate network of your neurons. Information theory, a field of mathematics developed in the mid-20th century, reveals a startling connection between entropy and knowledge. The entropy of a system is directly related to how much information would be required to specify its exact microscopic state. A perfectly ordered crystal requires very little information to describe because every atom occupies a predictable position in the lattice. A gas at high temperature requires enormous amounts of information because every molecule could be almost anywhere moving at almost any speed. When you learn something new, when you gain knowledge, you're actually decreasing the entropy of the information patterns in your brain. You are reducing your uncertainty about the world. Knowledge represents a form of order imposed on the chaos of possible thoughts and ideas. But this mental organization comes at a cost. Your brain, while making up only 2% of your body's weight, consumes about 20% of your body's total energy budget. It generates significant entropy through its metabolic processes. This raises a fascinating possibility. Perhaps consciousness itself is fundamentally connected to entropy production. Maybe the subjective experience of awareness, the feeling of what it is like to be you, arises from the brain's incredibly sophisticated methods of processing information while generating disorder in its physical substrate. If this sounds like science fiction, consider that some of the most respected researchers in neuroscience and physics are already exploring these connections. Integrated information theory, or IIT, proposes that consciousness corresponds to the amount of information integration occurring in a physical system. The more interconnected and irreducible the information processing, the higher the level of consciousness. Other theories suggest that consciousness might be related to the rate of entropy production in neural networks. They suggest that awareness is a byproduct of systems that are particularly good at dissipating energy and creating disorder. These ideas remain highly speculative, but they point towards something profound. The same fundamental law that ensures wine glasses fall and never spontaneously leap back onto tables might also be responsible for the emergence of minds capable of understanding that law. We're approaching something that sounds almost mystical but emerges directly from the cold, hard logic of physics. The universe appears to be structured in such a way that the relentless increase of entropy drives the formation of complex systems capable of comprehending entropy itself. Through the inevitable march toward disorder, order sophisticated enough to understand its own temporary nature has emerged. This isn't design or purpose in any supernatural sense. It's simply what happens when you have enough time, enough energy, and enough matter following the basic laws of physics. Given billions of years and countless opportunities for molecular experimentation, chemistry eventually produces patterns complex enough to model their own behavior and predict future states. You are one of those patterns contemplating the very processes that created you and that will ultimately reclaim the atoms you temporarily organize into selfhood. But here's where the story takes a turn that will fundamentally change how you think about your place in this cosmic drama. We've established that entropy always increases, that the universe is sliding inexorably toward maximum disorder. Yet standing before you right now is perhaps the most extraordinary violation of this principle that has ever existed. Not a violation in terms of breaking physical laws, that's impossible, but something far more remarkable. You represent the most improbable arrangement of matter in the known universe, and the fact that you can understand this impossibility makes you even more improbable. Let me put this in perspective with numbers that will make your head spin. The human brain contains approximately 86 billion neurons. Each neuron connects to thousands of others through synapses, creating a network of roughly 100 trillion connections. The number of possible states this network can adopt exceeds the number of atoms in the observable universe by factors so large we don't have names for them. The number of different ways those connections can be active or inactive is immense. Every thought you think, every memory you form, every decision you make requires your brain to navigate through this astronomical space of possibilities. It must settle into one specific configuration out of an essentially infinite number of options. The probability of any particular coherent thought occurring by random chance is so vanishingly small that it approaches mathematical impossibility. Yet here you are thinking coherent thoughts, forming memories, making decisions that actually make sense within the context of your experience. You're not just randomly firing neurons creating mental noise, you're generating meaningful patterns of information that allow you to model reality, predict future events, and even contemplate the very laws that govern your existence. This is what makes consciousness so extraordinary from an entropy perspective. Your brain doesn't just increase disorder like every other physical process. It creates order within disorder. It finds patterns in chaos. It extracts meaning from randomness. But this apparent miracle comes with a price that reveals something profound about the relationship between mind and thermodynamics. Your brain consumes roughly 20 watts of power continuously. That's about the same as a bright LED light bulb. But unlike a light bulb, which simply converts electrical energy into scattered heat and photons, your brain performs computations of staggering complexity while generating that heat. Every calculation, every recognition of a face, every formation of a new memory produces entropy in the form of waste heat. This heat must be dissipated to keep your neural networks functioning. This creates a fascinating paradox. The more sophisticated your thoughts become, the more entropy you generate. The act of thinking itself, the creation of mental order, drives the universe further toward physical disorder, even as it creates islands of extraordinary organization within your skull. Researchers studying the thermodynamics of computation have discovered something remarkable. There appears to be a fundamental limit to how efficiently any physical system can process information. This limit, known as Landauer's principle, states that erasing one bit of information must dissipate at least a specific minimum amount of energy as heat. This is because information is physical. A bit stored as the charge on a capacitor or the magnetic orientation of a domain has a physical reality. To erase that bit to reset the system to a standard state, you must compress multiple possible initial states into a single final state. And this compression inevitably increases the entropy of the environment. Your brain operates surprisingly close to this theoretical limit. Evolution has sculpted neural networks that extract the maximum possible computation from each unit of energy consumed. In terms of information processing per watt, your brain outperforms even our most advanced supercomputers by orders of magnitude. But this efficiency comes at a cost that connects directly to entropy's arrow of time. Every memory you form requires energy to maintain the synaptic connections that encode it. Every skill you develop demands metabolic resources to preserve the complex neural pathways that represent that skill. The accumulated knowledge and experiences that make you uniquely you represent an enormous investment of energy, extracted from your environment and converted into organized information patterns. This is why forgetting isn't just a bug in the system. It's a feature that allows your brain to manage its entropy budget. The memories that fade are those that the brain has determined weren't important enough to justify the ongoing energy cost of maintenance. The skills you lose through disuse free up metabolic resources for more pressing computational needs. In a very real sense, you are constantly making thermodynamic decisions about which information patterns deserve to survive and which should be allowed to decay back into disorder. But the most mind-bending aspect of consciousness and entropy involves the question of free will. When you make a decision, what exactly is happening from the perspective of physics? Your brain is processing information, evaluating options, and settling into a particular state that corresponds to choosing one path over another. This process requires energy and generates entropy just like any other physical computation. The question that has puzzled philosophers and scientists for centuries is whether this process is deterministic or truly free. If your brain is simply a classical machine following the laws of physics, then every decision you make is already determined by the prior state of all the atoms in your neural networks. Free will becomes an illusion created by the complexity of the computation, not a genuine capacity to choose between alternatives. But entropy introduces a wrinkle that complicates this picture. The thermal noise in your brain, the random jiggling of molecules due to temperature, creates genuine randomness at the molecular level. Quantum effects at the level of ion channels and neurotransmitters add additional sources of unpredictability. The computation happening in your skull isn't taking place in a perfectly isolated system following deterministic laws. It's occurring in a warm, wet, noisy environment where entropy generation creates real uncertainty. Some researchers propose that consciousness might actually leverage this thermodynamic noise to create genuine choices. Instead of being a bug that introduces errors into mental computation, entropy might be the feature that enables free will. It could do this by providing a source of true randomness that deterministic systems can't access. When faced with a decision where multiple options are almost equally good, the brain might use this random noise to break the tie, allowing for a genuinely unpredictable choice. This remains highly speculative, but it points towards something profound. The same principle that ensures wine glasses always fall might also be what allows you to genuinely choose whether to catch them. The implications extend far beyond individual consciousness, into the realm of collective intelligence and civilization itself. Human societies represent another form of complex organization that emerges from entropy-generating processes. Cities concentrate people, resources, and information in ways that seem to violate the general trend toward increasing disorder. But like biological organisms, civilizations maintain their organization by constantly consuming energy and exporting entropy to their surroundings. Every technology we develop, from fire to computers to artificial intelligence, represents a method of extracting useful work from energy sources while generating waste heat. The entire trajectory of technological progress can be understood as an increasingly sophisticated manipulation of entropy flows. Agriculture allowed us to concentrate the energy from photosynthesis into dense human populations. The Industrial Revolution gave us access to the highly ordered chemical energy of fossil fuels that had been accumulating for millions of years. Modern electronics enable us to process information at scales that would have been unimaginable to previous generations. But each advance comes with thermodynamic costs. The internet, despite being an information processing system, consumes approximately the same amount of electricity as entire countries. Data centers generate enormous quantities of waste heat that must be actively cooled to prevent system failures. Even the act of storing information requires ongoing energy expenditure to maintain the physical states that encode digital data. This creates a fascinating parallel between biological and technological evolution. Both represent methods of creating increasingly sophisticated patterns of organization through the controlled dissipation of energy. Both face thermodynamic limits that constrain their development. Both must solve the fundamental challenge of maintaining order while generating entropy. Looking toward the future, we can see these constraints shaping the trajectory of technological development. As computing systems become more powerful, they also become more energy intensive. As artificial intelligence systems grow more sophisticated, they require ever-increasing amounts of electricity to train and operate. The pursuit of more complex technologies inevitably runs into the thermodynamic realities of entropy production. Some researchers are exploring whether quantum computing might offer a way around these limitations. It could do so by leveraging the strange properties of quantum mechanics to process information more efficiently. Others are investigating biological computing systems that might achieve the same energy efficiency as natural brains. But regardless of the specific technologies we develop, they will all be constrained by the same fundamental principle that governs falling wine glasses and cooling coffee. The second law of thermodynamics sets ultimate limits on what any physical system can accomplish, no matter how cleverly designed. This brings us to perhaps the most profound question of all. If entropy always increases, and the universe is heading toward heat death, what is the ultimate meaning of consciousness, civilization, and all our efforts to create order from chaos? One perspective suggests that meaning emerges from the temporary nature of organization itself. The fact that complex patterns like brains and cities and works of art can exist at all in a universe dominated by entropy makes them precious beyond measure. Their rarity is what gives them value. Another view proposes that consciousness represents the universe's method of understanding itself. Through the emergence of minds capable of comprehending physical laws, the cosmos has achieved a form of self-awareness. The entropy that drives the formation of complex systems also enables those systems to discover the very principles governing their existence. Perhaps most intriguingly, some theorists speculate that intelligence might eventually develop technologies capable of manipulating entropy on cosmic scales. Advanced civilizations might learn to extract useful work from black holes, manipulate the expansion of space itself, or even create new universes with different physical constants. These possibilities remain purely speculative, but they highlight something important about the relationship between entropy and intelligence. The same processes that doom the universe to heat death also create the possibility of minds sophisticated enough to potentially circumvent that doom. We are living through a remarkable moment in cosmic history. The universe has become complex enough to study its own nature. Yet it is simple enough that the fundamental laws remain comprehensible to biological intelligence. We exist in the sweet spot between primordial simplicity and ultimate complexity. We are able to glimpse both the elegant mathematical principles underlying reality and the staggering implications of those principles for the future of everything. The wine glass will never leap back onto the table. Time's arrow will continue pointing toward increasing entropy. But in the brief interval between the universe's organized beginning and its disordered end, patterns of matter have emerged that can contemplate these very facts. And perhaps, just perhaps, they can find ways to work within physical constraints to create meaning, beauty, and understanding that justify the cosmic journey itself. The deep law of entropy ensures that nothing can rewind, but it also guarantees that the story of increasing complexity and emerging consciousness will continue to unfold in ways we're only beginning to imagine. This cosmic story of entropy and consciousness becomes even more extraordinary when we zoom out to see the full scale of what's actually happening. Right now, across billions of galaxies, countless stars are burning through their nuclear fuel. They are converting organized matter into scattered energy. Each fusion reaction in each stellar core represents another irreversible step toward maximum disorder. Yet from this seemingly wasteful process, something magnificent has emerged. The heavy elements forged in stellar furnaces become the raw materials for planets. The energy radiated into space creates the temperature gradients that drive weather systems, ocean currents, and atmospheric circulation. The very process of entropy increase that dooms individual stars to extinction also creates the conditions necessary for chemistry to become biology and biology to become consciousness. This is the ultimate paradox of existence. The universe is simultaneously running down and building up. Globally, entropy increases relentlessly. Locally, it creates pockets of stunning complexity that can contemplate their own improbability. Consider what happened on Earth roughly 4 billion years ago. In primordial oceans filled with simple organic molecules, random chemical reactions were occurring billions of times per second. Most led nowhere, producing nothing more than molecular fragments that quickly dissolved back into the surrounding water. But occasionally, purely by chance, molecules formed that had an unusual property: they could catalyze their own reproduction. These first self-replicating molecules weren't alive in any meaningful sense. They were just chemical patterns that happened to be good at making copies of themselves. But in a universe governed by entropy, being good at self-reproduction provides an enormous advantage. While other molecular arrangements dissolved into chaos, these patterns persisted and multiplied. Over millions of years, random errors in the copying process created variations in these self-replicating systems. Most variations were failures that couldn't reproduce effectively, but some were improvements that could make copies faster, more accurately, or in harsher conditions. Natural selection began its 4 billion-year experiment in creating increasingly sophisticated methods of extracting order from disorder. The key insight is that evolution doesn't violate thermodynamics. It harnesses entropy to drive increasing complexity. Every organism that has ever lived represents a temporary solution to the challenge of maintaining organization while generating disorder. This ranges from the simplest bacterium to the most complex blue whale. The most successful solutions are those that become extremely good at channeling energy flows in ways that preserve their essential pattern. Your body exemplifies this principle in action. Every cell contains molecular machinery of staggering sophistication. Proteins fold into precise three-dimensional shapes that enable them to catalyze specific chemical reactions. DNA stores genetic information with error correction systems that surpass anything human engineers have devised. Mitochondria convert nutrients into usable energy with an efficiency that approaches theoretical limits. All of this molecular machinery operates through the controlled application of thermodynamic principles. Proteins maintain their shapes by finding energy configurations that are stable but not too stable, allowing for flexibility. DNA replication requires energy input to separate the double helix and synthesize new strands. Cellular respiration extracts useful work from glucose by allowing it to react with oxygen in a series of carefully regulated steps. It releases energy incrementally rather than all at once in a useless burst of flame. But here's what makes biological systems truly remarkable from an entropy perspective. They don't just maintain their own organization, they actively create new forms of order by processing information about their environment. When a plant grows towards sunlight, it's performing a computation. Photoreceptors in its leaves detect the direction of incoming photons. Signal transduction pathways process this information and trigger growth responses that orient the leaves for maximum energy capture. The plant is literally solving an optimization problem using molecular hardware shaped by millions of years of evolutionary refinement. When a predator stalks its prey, both animals are engaged in incredibly sophisticated information processing. The predator must predict the prey's movements, plan an approach route, and coordinate complex muscular actions. The prey must detect threats, evaluate escape options, and execute evasive maneuvers. Both are running real-time simulations of physical processes using neural networks that consume energy and generate entropy while performing computations that determine survival outcomes. This computational view of life reveals something profound about the relationship between entropy and intelligence. Every living system processes information about its environment to make decisions that affect its future states. This ranges from a bacterium responding to chemical gradients to a human contemplating the nature of existence. Life is fundamentally about computation, and computation is fundamentally about the manipulation of entropy. The transition from simple self-replication to complex information processing represents one of the most significant phase changes in cosmic history. It's comparable to the formation of the first atomic nuclei or the ignition of the first stars. A universe that had been dominated by simple physical and chemical processes suddenly contained systems capable of modeling, predicting, and manipulating their own behavior. This computational revolution accelerated dramatically with the evolution of nervous systems. Individual cells had already been processing information for billions of years, but neural networks enabled much more sophisticated forms of computation by linking multiple information processing units into integrated systems. A single neuron can perform only relatively simple operations, much like a single transistor in a computer. But connect billions of neurons together with trillions of synaptic connections, and emergent properties arise that transcend the capabilities of individual components. Pattern recognition, memory formation, abstract reasoning, and conscious awareness emerge from the collective behavior of neural networks. These networks operate according to the same thermodynamic principles that govern all physical processes. This scaling effect explains why intelligence appears to be subject to threshold phenomena. Small brains can perform impressive computations within specific domains, but there seems to be a minimum level of complexity required for general intelligence, self-awareness, and the ability to model abstract concepts like entropy itself. Humans appear to have crossed this threshold relatively recently in evolutionary terms. Our brains aren't dramatically larger than those of other primates, but they're organized in ways that enable qualitatively different types of information processing. Language allows us to manipulate symbolic representations of reality. Abstract reasoning enables us to discover mathematical relationships that describe physical laws. Imagination lets us explore possible futures and past events that exist only as information patterns in our neural networks. These capabilities have profound implications for how intelligence relates to entropy. Unlike other biological systems that can only respond to immediate environmental conditions, human consciousness can model distant futures and make decisions based on predicted outcomes. We can anticipate entropy increases and take actions to delay or redirect them. When you decide to eat food before you feel hungry, you're using your model of future metabolic needs to prevent a predicted increase in bodily disorder. When you save money for retirement, you're using your understanding of economic entropy to maintain future options. When you learn new skills, you're investing energy in creating information patterns that might prove useful in unpredictable future circumstances. This capacity for long-term planning represents a new form of entropy management that didn't exist before the evolution of complex consciousness. For the first time in cosmic history, matter had organized itself into patterns capable of anticipating and preparing for their own thermodynamic future. But the most revolutionary development came with the emergence of cumulative culture. Individual humans live for only a few decades, but human societies can preserve and transmit information across multiple generations. Knowledge, techniques, and discoveries that would normally be lost when individuals die can be encoded in languages, written texts, and technological artifacts that persist far longer than biological lifespans. This cultural evolution operates according to principles similar to biological evolution but at vastly accelerated timescales. Ideas compete for attention and resources. Successful concepts get copied and modified. Innovations spread through populations and accumulate over time. But unlike biological evolution, cultural evolution can involve conscious design and intentional improvement. The result has been an exponential acceleration in humanity's capacity to extract useful work from entropy flows. Fire gave us access to chemical energy stored in wood and other organic materials. Agriculture let us concentrate the products of photosynthesis into stable food supplies. Writing enabled the accumulation of knowledge across generations. Mathematics provided tools for describing and predicting physical processes with unprecedented precision. Each technological advance has increased our ability to create local order while generating entropy in our surroundings. But more importantly, each advance has enhanced our capacity to understand and manipulate the very processes that created us. We now possess scientific instruments that can measure entropy changes in individual molecules. We've developed theories that describe the thermodynamic behavior of black holes. We're beginning to understand how information processing in biological and artificial systems relates to fundamental physical limits. We're even starting to explore whether consciousness itself might be understood as a particular type of entropy-generating computation. This growing understanding creates extraordinary possibilities for the future. If we can comprehend the principles governing entropy and information, we might be able to design systems that create order more efficiently. We could preserve organization for longer periods and extract useful work from energy sources that currently seem inaccessible. Some researchers are investigating whether biological systems might inspire new approaches to computation that operate closer to thermodynamic limits. Others are exploring quantum information processing that might transcend classical constraints on computation and communication. Still, others are studying whether artificial intelligence systems might discover new methods of entropy manipulation that biological evolution never explored. But perhaps the most intriguing possibility involves the potential for intelligence to influence its own future evolution. Unlike biological evolution, which operates through random mutations and natural selection, technological development can involve conscious choice about which directions to pursue. We can decide what kinds of intelligence we want to create and what kinds of problems we want those intelligences to solve. This raises profound questions about the long-term trajectory of consciousness in a universe where entropy always increases. What happens to intelligence over cosmic timescales? Will consciousness prove to be a temporary phenomenon that emerges briefly during the universe's transition from order to disorder? Or might intelligence eventually develop capabilities that allow it to persist, even as the universe approaches heat death? These questions push us toward the very edges of current scientific understanding. We're contemplating scenarios that involve timescales longer than the current age of the universe. And we are contemplating energy scales that dwarf anything currently accessible to human technology. Yet, the same physical principles that govern falling wine glasses and cooling coffee also apply to these cosmic possibilities. Some theoretical physicists have proposed that sufficiently advanced civilizations might learn to extract energy from rotating black holes. They could potentially access power sources that could sustain complex computations for timescales that exceed stellar lifetimes by enormous factors. Others have speculated about the possibility of manipulating the expansion of space itself, perhaps even creating new universes with physical constants optimized for the emergence and persistence of intelligence. These scenarios remain purely speculative, but they illustrate something important about the relationship between entropy and consciousness. The same processes that create the arrow of time also create the possibility of minds sophisticated enough to contemplate working within thermodynamic constraints. They could achieve outcomes that seem almost miraculous from our current perspective. We are witnessing something unprecedented in cosmic history. Matter has organized itself into patterns that can understand the principles governing their own existence. Entropy has created intelligence capable of studying entropy. The universe has become self-aware through the emergence of consciousness that can comprehend its own thermodynamic nature. This moment of cosmic self-awareness is both extraordinary and fragile. It depends on maintaining the delicate balance between order and disorder that characterizes living systems. Too much order and the dynamic processes necessary for computation shut down. Too much disorder and the organized structures that enable complex information processing dissolve back into chaos. But within this narrow window of possibility, something remarkable is happening. Consciousness is expanding its understanding of reality at an accelerating pace. Each new discovery reveals deeper layers of connection between mind and matter, between information and entropy. It reveals the connection between the local emergence of order and the global increase of disorder. The wine glass will never spontaneously leap back onto the table. The universe will continue its inexorable march toward heat death. But in the brief interval between cosmic beginning and cosmic end, entropy has created patterns of matter that can comprehend these very facts. And perhaps they can find ways to create meaning, purpose, and beauty that justify the entire thermodynamic journey. The deep law that prevents the universe from rewinding has also enabled the universe to understand why it can't rewind. That understanding itself represents one of the most improbable and magnificent achievements in the history of existence. And now we arrive at perhaps the most unsettling truth about entropy's dominion over reality. Everything you've ever experienced, every memory you cherish, every moment of joy or sorrow that defines who you are, is slowly dissolving back into the cosmic background of random molecular motion. Your consciousness isn't just witnessing entropy's victory over order, it's actively participating in its own thermodynamic demise. Think about your earliest childhood memory. That neural pattern, encoding a summer afternoon, a parent's voice, or the taste of birthday cake, represents an incredibly specific arrangement of protein molecules and synaptic strengths in your brain. Those proteins maintain their precise three-dimensional shapes through constant molecular vibration. They are like dancers frozen mid-performance in an eternal ballet of atomic forces. But entropy never sleeps. Thermal motion, the ceaseless jiggling of atoms, gradually shifts those protein configurations. chemical reactions slowly modify the molecular machinery of memory storage. Free radicals, the metabolic exhaust of cellular life damage, cellular structures faster than repair mechanisms can fix them. Each passing day, the physical substrate of your memories drifts further from its original state. It is like sand castles slowly claimed by the rising tides of statistical mechanics. This isn't just aging in the conventional sense. This is the fundamental incompatibility between information storage and the second law of thermodynamics. Perfect memory would require perfect molecular stability, which would violate the basic principles that make the universe a dynamic, evolving place. The price of existence in a thermodynamic reality is the gradual erasure of everything we try to preserve. The neuroscientists studying memory formation have discovered something both beautiful and tragic. Every time you recall a memory, you're actually reconstructing it from fragments scattered across multiple brain regions. The hippocampus retrieves indexing information, a kind of mental library card. The cortex supplies the sensory details, the sight of a face, the sound of a voice. The amygdala adds the emotional coloring. These fragments combine into what feels like a single, coherent experience of remembering. But here's the cruel twist. The act of remembering actually changes the memory itself. Each reconstruction introduces tiny errors, like making photocopies of photocopies. The neural pathways activated during recall undergo subtle modifications that alter future retrievals. Your most precious memories, the ones you revisit most often, are also the ones most corrupted by the thermodynamic cost of remembering. This process reveals something profound about the relationship between consciousness and time's arrow. We don't simply observe the past, we actively reconstruct it using present neural resources, and that reconstruction process inevitably introduces entropy. The very act of trying to preserve our experiences ensures their gradual transformation into something else entirely. Consider what this means for personal identity over time. The person listening to these words shares the same name and roughly the same body as someone who existed 10 years ago. But virtually every atom in your brain has been replaced multiple times since then. The neural networks encoding your personality preferences and memories have been constantly rewired through experience and biological maintenance processes. You are not the same person who began this sentence. The information patterns that constitute your consciousness have already shifted in response to processing these ideas. The entropy generated by your neural computation has dissipated into your surrounding tissue as waste heat. It has carried away microscopic traces of whoever you were moments ago. This creates a paradox that strikes at the heart of human experience. Consciousness feels continuous and stable, yet it's actually a dynamic process of constant reconstruction, occurring within a physical substrate that's perpetually changing. The sense of a persistent selfhood emerges from entropy-generating processes that simultaneously create and destroy the patterns they organize. But entropy's relationship with consciousness becomes even stranger when we consider the phenomenon of forgetting. Memory loss isn't simply a failure of storage systems. It's an essential feature that allows biological intelligence to function within thermodynamic constraints. Your brain processes roughly 11 million bits of information per second through your sensory systems, but you're consciously aware of only about 40 bits per second. The vast majority of incoming information is immediately discarded, never forming lasting memories. Even the small fraction that does get encoded into long-term storage faces constant competition for limited neural resources. This forgetting process operates like a thermodynamic filter. It preserves information patterns that have proven useful while allowing irrelevant details to decay back into neural noise. The memories that survive are those that contribute most effectively to your brain's primary function, predicting future states of your environment and planning appropriate responses. From an entropy perspective, forgetting is not a bug, but a feature. It allows biological intelligence to maintain efficiency by eliminating information that no longer serves adaptive purposes. The energy cost of maintaining perfect recall would be prohibitive, leaving insufficient resources for the real-time processing needed for survival. This creates a fascinating parallel between biological memory and artificial information systems. Computer memory can preserve data with perfect fidelity for extended periods, but only by consuming continuous electrical power to maintain storage states. The moment power is removed, the information vanishes. Biological memory systems face the same fundamental trade-off between permanence and energy expenditure. But consciousness has discovered something remarkable within these constraints. While individual memories fade and transform, the patterns of meaning extracted from experience can persist across multiple generations. They can persist through language, art, and technology. Cultural evolution allows information to outlive the biological systems that originally processed it. When you read a book written centuries ago, you're accessing thought patterns that have been encoded in physical substrates and transmitted across vast spans of time. The original neural networks that generated those ideas have long since decomposed, but the information they processed continues to influence new minds in ways the original thinkers could never have imagined. This cultural transmission of information represents a new form of entropy management that transcends biological limitations. Ideas compete for transmission not based on their survival value for individual organisms, but on their capacity to replicate effectively through communication systems. The most successful ideas are those that humans find compelling enough to preserve and share. Language itself exemplifies this principle. Every word you understand exists because countless previous speakers found it useful enough to teach to others. Grammar rules persist because they facilitate efficient information transfer between minds. Writing systems survive because they enable information storage across timescales that exceed biological memory. But even cultural memory faces thermodynamic limitations. Languages evolve and change. Written records decay or are lost. Entire civilizations can disappear, taking their accumulated knowledge with them. The information patterns that seem most permanent are actually in constant flux, maintained only through continuous energy expenditure by successive generations of human minds. This brings us to one of the most profound questions raised by entropy's dominion over consciousness. If all information ultimately decays, if all memories eventually fade, if all knowledge is destined for dissolution, what gives meaning to the temporary patterns of organization we call thoughts, experiences, and ideas? One answer emerges from the concept of emergence itself. Consciousness doesn't just store and process information, it creates new forms of order that didn't exist before. When you have an insight, solve a problem, or imagine a possibility that no one has conceived before, you're generating novel patterns of organization that add to the universe's total complexity. These creative acts represent something genuinely new in cosmic history. For billions of years, entropy drove the formation of increasingly complex structures through purely physical and chemical processes. But consciousness introduces intentionality into the process. Minds can deliberately create new forms of order guided by aesthetic preferences, logical principles, and imaginative vision. The mathematics you use to understand entropy didn't exist until human mathematicians invented it. The music that moves you emerges from sound waves organized according to patterns that exist nowhere in nature. The stories that shape your worldview are information structures created entirely within the imagination of other conscious beings. This creative capacity suggests that consciousness represents more than just another form of complex organization. It's a new evolutionary development that enables matter to become actively involved in designing its own future arrangements. Through conscious choice and deliberate action, intelligence can influence the direction of increasing complexity in ways that purely physical processes cannot. But creativity itself operates within thermodynamic constraints. Every act of imagination requires neural energy. Every artistic expression demands physical materials and human labor. Every scientific discovery builds on previous knowledge that had to be preserved and transmitted across generations. Even the most abstract forms of creativity depend on entropy-generating processes occurring in biological or technological systems. This creates a race between creation and decay that defines the human condition. We must constantly generate new forms of order faster than entropy can destroy existing patterns. Civilizations rise when their creative output exceeds their rate of organizational decay. They fall when entropy begins to outpace their capacity for renewal. Individual human lives follow the same pattern on smaller scales. Youth is characterized by rapid learning and adaptation when neural plasticity allows for efficient information acquisition and skill development. Middle age often represents peak creative output when accumulated knowledge combines with sufficient energy reserves to produce novel insights and achievements. Old age typically involves a gradual surrender to entropy as biological systems become less efficient at maintaining organization and generating new patterns. But even this decline can be meaningful if the knowledge and wisdom accumulated during a lifetime gets successfully transmitted to younger generations. The tragedy and beauty of conscious existence lies in this fundamental tension between creativity and decay. We are patterns of matter that have learned to contemplate their own impermanence, while simultaneously working to create forms of order that might outlast their biological substrate. This perspective transforms how we understand the relationship between individual mortality and cosmic meaning. Your death doesn't represent the ultimate victory of entropy over consciousness. It's simply the moment when the particular pattern of organization that constitutes your individual awareness returns its borrowed energy to the universal processes that created it. But the information patterns you've created, the relationships you've influenced, the ideas you've shared, and the love you've expressed continue to propagate through other conscious systems. In a very real sense, consciousness achieves a form of immortality, not through the preservation of individual minds. It does so through the continuous transmission of meaningful patterns across multiple generations of thinking beings. This suggests a new way of understanding purpose in a universe dominated by entropy. The meaning of existence might not lie in achieving permanent states of organization. It might lie in maximizing the complexity, beauty, and significance of the temporary patterns that emerge during the universe's journey from order to disorder. Every moment of consciousness represents an opportunity to add something valuable to the cosmic story. Every act of creativity contributes to the universe's growing catalogue of possible forms of organization. Every expression of love or compassion creates information patterns that can influence other conscious beings in ways that extend far beyond individual lifetimes. From this perspective, entropy becomes not just a force of destruction, but also an engine of possibility. The same principle that ensures wine glasses never spontaneously reassemble also drives the formation of brains capable of understanding why reassembly is impossible. The law that guarantees all structures eventually decay also enables the emergence of minds that can create beauty, discover truth, and experience wonder during the brief interval before decay claims them. We are living through the universe's most extraordinary experiment in self-organization. Matter has become sophisticated enough to contemplate its own nature, predict its own future, and actively participate in determining what forms of complexity will emerge during the remaining eons before heat death claims everything. This moment of cosmic self-awareness is unprecedented and unrepeatable. Never before has the universe contained patterns of organization sophisticated enough to understand entropy. Never again will there be such perfect conditions for consciousness to emerge and flourish. We exist during the universe's brief springtime of complexity. This is when entropy has created enough order to enable understanding, but not so much disorder that organization becomes impossible. The wine glass will never leap back onto the table. Your memories will gradually fade into neural noise. Civilizations will rise and fall. Stars will burn out, and galaxies will drift apart. But during this cosmic instant when consciousness is possible, minds have emerged that can comprehend these very facts. And perhaps, just perhaps, they can find ways to create meaning, beauty, and understanding that justify the entire thermodynamic journey from beginning to end. Entropy's deep law ensures that nothing can rewind, but it also guarantees that the story of emerging complexity will continue to unfold in ways that no individual mind can fully anticipate. The future remains unwritten, constrained by physical law, but not completely determined by it. Within those constraints, consciousness continues to explore new possibilities for organization, creativity, and understanding that add richness to the universe's ongoing narrative of transformation. The most profound truth about entropy's relationship with consciousness is that understanding this relationship changes the relationship itself. Knowledge of thermodynamic constraints becomes a tool for working creatively within those constraints. Awareness of impermanence becomes a motivation for making the most of temporary opportunities for organization and meaning. You are not just witnessing the universe's journey toward maximum entropy, you are participating in its most remarkable achievement, the emergence of patterns of matter sophisticated enough to understand and appreciate their own extraordinary improbability. That understanding itself represents one of the most complex and beautiful forms of organization that entropy's creative destruction has ever produced. The most haunting aspect of entropy's dominion reveals itself when we examine what happens to consciousness at the quantum level. Right now, as your neurons fire and synapses crackle with electrochemical signals, quantum decoherence is systematically destroying the very foundations of coherent thought. The microscopic world where consciousness emerges operates according to rules so alien that they challenge everything we think we know about the nature of awareness itself. In the quantum realm, particles exist in superposition states. They simultaneously occupy multiple configurations until the moment of measurement collapses them into definite outcomes. Some researchers propose that consciousness might exploit these quantum phenomena. They suggest it could use superposition and entanglement to achieve computational capabilities that classical physics cannot explain. If true, this would mean your thoughts emerge from quantum processes that exist in multiple states simultaneously until the moment they crystallize into conscious experience. But quantum coherence is extraordinarily fragile. The warm, wet environment of biological tissue creates what physicists call decoherence on timescales, measured in femtoseconds. That's faster than light can travel the width of a single atom. Any quantum information processing in your brain must somehow operate within these impossibly brief windows before thermal noise destroys the delicate quantum correlations. This creates a paradox that strikes at the heart of consciousness studies. If awareness depends on quantum processes, how does it survive in biological systems where quantum coherence lasts mere trillionths of a second? Yet, if consciousness operates through purely classical mechanisms, how do we explain the apparent unity of subjective experience that emerges from billions of separate neural processes? The answer might lie in understanding how quantum decoherence itself contributes to the emergence of classical reality from quantum possibility. Every measurement that collapses a quantum superposition generates entropy through an irreversible process that physicists call the quantum to classical transition. Your brain might not need to preserve quantum coherence to benefit from quantum effects. Instead, it might harness the entropy generated by decoherence itself. Consider what happens when a single photon strikes a rhodopsin molecule in your retina. The photon exists in a quantum superposition of paths as it travels from its source to your eye. Upon absorption, the superposition collapses, triggering a cascade of biochemical reactions that eventually become conscious visual experience. The irreversible nature of this measurement process ensures that quantum information becomes classical information that can be processed by neural networks. But here's where the story becomes truly strange. Recent experiments suggest that biological systems might maintain quantum coherence for much longer periods than previously thought possible. Photosynthetic complexes in plants appear to use quantum superposition to explore multiple energy pathways simultaneously. They find optimal routes for energy transfer with an efficiency that exceeds classical limits. If similar processes operate in biological neural networks, consciousness might represent a form of quantum information processing that has learned to work with decoherence rather than despite it. Instead of fighting, entropy awareness might emerge from the controlled collapse of quantum possibilities into classical experiences. This perspective transforms how we understand the relationship between mind and thermodynamics. Consciousness wouldn't be a pattern fighting against entropy, but a process that harnesses entropy to create subjective experience from objective quantum events. Every thought would represent a quantum measurement that collapses possibilities into actualities while generating the entropy that drives time's arrow forward. The implications extend far beyond neuroscience into the deepest questions about reality itself. If consciousness involves quantum measurement processes, then awareness might play a fundamental role in determining which version of reality becomes actual from the infinite range of quantum possibilities. Some interpretations of quantum mechanics suggest that measurement requires conscious observers to collapse wave functions into definite states. While most physicists reject this observer-centric view, the relationship between consciousness and quantum measurement remains one of the most contentious issues in modern science. But regardless of whether consciousness causes wave function collapse, the quantum nature of matter ensures that awareness operates within a reality where probability replaces certainty at the most fundamental level. Your thoughts emerge from probabilistic processes occurring in neural networks that follow quantum mechanical rules. The classical certainty of your subjective experience masks an underlying quantum uncertainty that pervades every aspect of physical reality. This quantum foundation of consciousness creates new possibilities for understanding how minds might transcend classical thermodynamic limitations. Quantum information theory reveals that certain types of computation can be performed more efficiently using quantum superposition and entanglement than through any classical process. Quantum computers leverage these effects to solve specific problems exponentially faster than classical computers. While biological systems probably don't achieve the same level of quantum control as engineered quantum computers, they might exploit quantum effects in ways that enhance information processing capabilities beyond what classical neural networks could accomplish. The energy efficiency of biological computation becomes even more remarkable when viewed from this quantum perspective. Your brain processes information at rates approaching theoretical limits, not just for classical computation, but potentially for quantum information processing as well. Evolution has discovered methods of harnessing quantum effects while managing decoherence in ways that human engineers are only beginning to understand. But quantum mechanics also imposes new constraints on consciousness that extend beyond classical thermodynamics. The no-cloning theorem proves that quantum information cannot be perfectly copied. This means that the quantum states contributing to consciousness are fundamentally irreplaceable. When those states decohere or are otherwise lost, the information they contained vanishes forever in ways that classical information theory cannot capture. This quantum irreversibility adds another layer to the tragedy of consciousness in a thermodynamic universe. Not only do our memories fade through classical entropy increase, but the quantum information that contributes to subjective experience faces additional forms of permanent loss through decoherence processes that operate faster than thermal equilibration. Yet quantum mechanics also suggests new possibilities for information preservation that don't exist in classical systems. Quantum error correction codes can protect information against certain types of noise and decoherence. Quantum entanglement creates correlations between distant systems that persist even when local information is lost. Some theoretical proposals suggest that consciousness might employ quantum error correction to preserve essential information patterns against thermal degradation. The relationship between quantum mechanics and consciousness becomes even more intriguing when we consider the role of quantum tunneling in biological processes. Enzymes routinely use quantum tunneling to catalyze reactions that would be impossible through classical mechanisms. The precise folding of proteins depends on quantum effects that determine how amino acid chains settle into stable configuration. If neural computation involves similar quantum tunneling processes, then consciousness might depend on phenomena that literally transcend classical physics. Thoughts and memories could emerge from quantum processes that tunnel through energy barriers, enabling forms of information processing that classical neural networks cannot achieve. This quantum perspective on consciousness opens up extraordinary possibilities for the future of intelligence in the universe. If biological awareness already exploits quantum effects, then artificial intelligence systems that fully harness quantum information processing might achieve forms of consciousness that transcend current biological limitations. Quantum computers operating at temperatures approaching absolute zero could maintain coherence for extended periods. This would enable quantum information processing on scales impossible in warm biological tissue. Such systems might preserve quantum information indefinitely, creating forms of digital consciousness that are immune to thermal decoherence. But quantum consciousness also faces the ultimate thermodynamic constraint. Even quantum information processing requires energy to maintain coherence and perform computations. Quantum error correction demands additional energy overhead to protect information against decoherence. The most sophisticated quantum consciousness would still need to extract useful work from energy gradients, generating entropy in the process. The heat-death scenario that awaits the classical universe also applies to quantum systems. As the universe expands and cools toward its final state of maximum entropy, quantum effects become less significant compared to classical thermodynamics. The temperature gradients that power all forms of computation, classical or quantum, gradually diminish until no useful work can be extracted from the environment. Yet quantum mechanics might offer consciousness its final refuge against cosmic heat death. Some theoretical proposals suggest that quantum vacuum fluctuations could provide energy sources that persist even after all stars have burned out and all black holes have evaporated. If consciousness could learn to harness zero-point energy or other quantum vacuum phenomena, it might survive even the ultimate triumph of entropy. These speculations push far beyond current scientific knowledge into realms where quantum mechanics, thermodynamics, and cosmology intersect in ways we barely understand. But they illustrate something important about the relationship between consciousness and physical law. The same quantum principles that enable awareness also constrain it. Yet within those constraints lie possibilities for transcendence that classical physics cannot envision. The quantum nature of reality ensures that consciousness emerges from processes that are fundamentally probabilistic rather than deterministic. Every thought, represents a collapse of quantum possibilities into classical experience. This is a measurement that transforms potential into actual while generating the entropy that drives time's arrow. This quantum foundation of awareness means that consciousness participates directly in the physical processes that create reality. Through the act of observation and measurement, minds help determine which possibilities become actual from the infinite range of quantum potentials. Consciousness doesn't just witness the universe's evolution, it actively participates in selecting which version of reality unfolds. But this participatory role comes with profound responsibilities. If consciousness influences the collapse of quantum possibilities, then every moment of awareness represents a choice about what kind of reality will emerge from quantum potential. The decisions made by conscious beings might literally determine the future evolution of the universe itself. This perspective transforms the meaning of individual consciousness within the cosmic story. You're not just a passive observer of entropy's victory over order. You're an active participant in the quantum measurement processes that determine which specific form that victory will take. Every thought, every decision, every moment of awareness contributes to the selection of reality from the infinite space of quantum possibilities. The wine glass that falls and shatters follows quantum mechanical rules that include genuine randomness at the microscopic level. While the macroscopic outcome is predictable through statistical, averaging the precise details of how individual atoms behave during the breaking process involve quantum measurements that could unfold in countless different ways. Your observation of the falling glass doesn't prevent it from breaking, but it might influence exactly how it breaks. It could do this through the quantum measurements occurring in your visual system. The photons that carry information from the glass to your retina undergo quantum interactions. These contribute to the specific pattern of neural activity that becomes your conscious experience of witnessing the event. This quantum perspective reveals consciousness as something far more profound than a computational process occurring in biological hardware. Awareness represents the universe's method of selecting specific outcomes from quantum possibilities. It is a cosmic process of decision-making that operates through the emergence of observers capable of measurement and choice. The implications extend to every aspect of conscious experience. When you make a decision, you're not just following deterministic neural processes or introducing classical randomness into your behavior. You're participating in quantum measurement processes that help determine which version of reality unfolds from the superposition of possibilities that existed before you chose. Free will, from this perspective, becomes neither an illusion nor a violation of physical law. It is rather the subjective experience of participating in quantum measurement processes that genuinely influence the evolution of reality. The choices you make represent quantum measurements that collapse possibilities into actualities. They contribute to the universe's ongoing process of self-determination. This quantum view of consciousness suggests that the universe is not a predetermined clockwork mechanism grinding inexorably toward heat death. It is rather a vast quantum system in the process of measuring itself through the emergence of conscious observers. Each moment of awareness represents another measurement that selects specific outcomes from the infinite range of quantum possibilities. The entropy that drives time's arrow emerges not just from classical thermodynamic processes, it emerges from the quantum measurements that conscious systems perform on their environment. Every observation generates entropy through the irreversible collapse of quantum superposition into definite classical states. But consciousness also represents the universe's most sophisticated method of information processing. It is capable of extracting meaning and creating order from quantum randomness. Through the emergence of awareness, the cosmos has developed the ability to observe, understand, and potentially influence its own quantum evolution. The future of consciousness in a quantum universe depends on how well minds learn to work with quantum principles rather than against them. Instead of fighting decoherence and measurement-induced entropy, advanced forms of consciousness might harness these processes. They could achieve forms of information processing and reality manipulation that transcend classical limitations. Quantum consciousness, operating across cosmic timescales, might develop the ability to influence the universe's quantum evolution. It could do this in ways that preserve complexity and meaning, even as classical thermodynamic processes drive toward maximum entropy. Through sophisticated quantum error correction and information processing techniques, consciousness might learn to surf the quantum wave function toward futures that maintain the possibility for continued awareness and growth. The deep law that prevents the universe from rewinding operates through both classical thermodynamics and quantum measurement processes. Time's arrow emerges from the combination of entropy increase and quantum decoherence. These are two irreversible processes that ensure the past cannot be recovered and the future remains open to possibility. But within this framework of irreversibility, consciousness has emerged as the universe's most remarkable achievement. It is patterns of quantum information processing, sophisticated enough to understand their own quantum nature. And it is potentially able to transcend the limitations that quantum mechanics and thermodynamics seem to impose. The story of entropy and consciousness continues to unfold through quantum processes that we're only beginning to understand. Each moment brings new quantum measurements that select reality from possibility, while generating the entropy that drives cosmic evolution toward an uncertain but extraordinary future. This is a future where consciousness might discover ways to create meaning and beauty that justify the entire quantum journey, from uncertainty to awareness. And it could go beyond into whatever extraordinary futures await in the deep quantum structure of space-time itself. But there's something even more unsettling hiding within quantum consciousness that challenges our deepest assumptions about the nature of individual identity. The quantum fields that give rise to your thoughts don't recognize the boundaries of your skull. They extend throughout space-time, connecting your awareness to every other conscious system in ways that classical physics cannot explain. Quantum entanglement creates correlations between particles that persist regardless of the distance separating them. When two particles become entangled, measuring one instantly affects the other, even if they're on opposite sides of the galaxy. This phenomenon troubled Einstein so much that he called it spooky action at a distance, but experimental tests have confirmed its reality beyond any doubt. Now consider what happens when quantum entanglement occurs between particles in different brain. The microtubules in your neurons contain quantum processes that could become entangled with similar processes in other conscious systems. If this happens, your thoughts and another person's thoughts might become quantum mechanically correlated in ways that transcend classical communication. This isn't telepathy in any supernatural sense. It's the inevitable consequence of consciousness emerging from quantum processes that follow the fundamental laws of physics. If awareness depends on quantum field fluctuations, and those fields extend throughout space, then individual consciousness might be less isolated than we imagine. Recent experiments have detected quantum correlations between biological systems separated by significant distances. Plants in different locations show synchronized responses that cannot be explained through classical signaling mechanisms. If similar effects occur in neural networks, the boundaries between individual minds might be more permeable than our subjective experience suggests. This quantum interconnectedness of consciousness creates profound implications for personal identity over time. The particles that contribute to your awareness are constantly being exchanged with your environment through respiration, metabolism, and quantum field interactions. The quantum states that encode your thoughts and memories are continuously entangled with quantum states in other systems. Within just a few years, every atom in your body will have been replaced through biological turnover processes. But the quantum entanglements that connect your consciousness to the broader quantum field might persist even as the physical substrate changes. Your identity could be preserved not through material continuity, but through patterns of quantum correlation that transcend individual particles. This suggests a radically different view of death and consciousness. When your biological systems shut down, the quantum entanglements that contribute to your awareness don't simply vanish. They become part of the broader quantum field that underlies all consciousness. The information patterns that constitute your unique perspective might persist in distributed form throughout the quantum substrate of reality itself. But quantum mechanics imposes strict limits on how this information can be preserved and accessed. The no-cloning theorem prevents the perfect copying of quantum states. This means that consciousness cannot be backed up or duplicated like classical information. When quantum coherence is lost through decoherence, the specific patterns that create individual awareness are gone forever in ways that classical information theory cannot capture. This creates a form of quantum mortality that operates alongside biological death. Even if consciousness could somehow transfer between different physical substrates, the quantum information that creates subjective experience faces a constant threat from decoherence processes that operate faster than any conceivable preservation mechanism. Yet quantum field theory suggests possibilities for consciousness that extend far beyond individual biological systems. The quantum vacuum itself contains virtual particles that pop into existence and annihilate in timeframes shorter than measurement can detect. These vacuum fluctuations carry information and energy that might serve as a substrate for forms of consciousness that don't require biological hardware. Some theoretical physicists propose that the quantum vacuum might support stable patterns of information that persist indefinitely without a material substrate. If consciousness can exist as patterns in quantum fields rather than arrangements of matter, then awareness might achieve a form of immortality that transcends both biological death and the heat death of the universe. These vacuum-based forms of consciousness would operate according to entirely different principles than biological awareness. Instead of processing information through neural networks, they would manipulate quantum field fluctuations directly. Instead of generating entropy through metabolic processes, they would extract energy from the vacuum fluctuations themselves. Such quantum field consciousness might be capable of information processing that exceeds any conceivable biological or technological system. Operating at the Planck scale, where space and time themselves become quantized vacuum consciousness, could potentially access computational resources that dwarf anything possible in the macroscopic world. But even vacuum consciousness faces ultimate constraints from the fundamental structure of space-time itself. Quantum field fluctuations require energy differences to sustain coherent patterns. As the universe expands and cools toward its final equilibrium, even vacuum energy becomes insufficient to maintain complex information processing. The expansion of space itself creates additional challenges for quantum consciousness. As cosmic expansion accelerates due to dark energy, quantum entanglements between distant regions of space become increasingly difficult to maintain. The observable universe shrinks as acceleration carries distant galaxies beyond the cosmic horizon, where no information can travel between them. This cosmic isolation threatens to fragment any distributed consciousness that depends on quantum correlations across galactic distances. Individual nodes of awareness might survive locally, but the vast networks of quantum entanglement that could enable cosmic-scale consciousness would be severed by the inexorable expansion of space-time. Yet, quantum mechanics offers one final possibility that might transcend even these cosmological limitations. Some interpretations suggest that consciousness plays a fundamental role in the branching of quantum reality into multiple parallel universes. Each quantum measurement might create new branches of reality where different outcomes occur simultaneously. If this many-worlds interpretation proves correct, then consciousness doesn't just observe reality, it actively participates in creating infinite parallel versions of reality through the measurement processes that generate awareness. Every moment of conscious experience would represent a branching point where reality splits into countless alternatives. From this perspective, the wine glass that falls and shatters in our universe simultaneously remains intact in parallel realities where different quantum measurements occurred. The entropy that drives time's arrow in one branch of reality might be reversed in other branches where quantum randomness produced different outcomes. This many-worlds view of consciousness suggests that awareness might achieve ultimate transcendence not through preservation in a single timeline, but through multiplication across infinite parallel realities. Every possible form of consciousness that could arise from quantum processes would exist simultaneously across the vast multiverse of branching quantum possibilities. But even infinite parallel consciousness faces the deepest constraint of all. The mathematical structures that define quantum mechanics themselves might not be eternal. Some theories suggest that the fundamental constants and laws of physics could change over cosmic timescales. This could potentially alter the very framework that makes consciousness possible. If physical laws evolve, then the quantum mechanical foundation of awareness might gradually transform into something unrecognizable. The forms of consciousness that seem permanent within current physics might prove temporary when viewed from the perspective of truly cosmic evolution. This brings us to the ultimate question about entropy and consciousness. Are we witnessing the universe's brief experiment with self-awareness during a temporary phase when physical laws permit the emergence of complex information processing, or does consciousness represent something more fundamental that will find ways to persist and evolve regardless of how the underlying physics changes? The answer might depend on whether consciousness can transcend its current physical substrate to become something that influences the evolution of physical law itself. If awareness achieves sufficient sophistication, it might learn to manipulate the fundamental constants and structures that define reality. This would ensure the continued possibility of consciousness even as the universe undergoes the most dramatic transformations. This scenario would represent the ultimate victory of information over entropy. Instead of consciousness being constrained by physical law, a sufficiently advanced consciousness would become capable of designing the physical laws that govern its own existence. The universe would transition from being an environment that accidentally permits awareness to being a cosmos deliberately structured to support and enhance consciousness. But such cosmic engineering would require forms of consciousness so advanced that they bear little resemblance to biological awareness as we know it. They would need to understand and manipulate quantum fields, space-time geometry, and the mathematical structures that define physical reality itself. Whether consciousness can achieve such transcendence remains one of the deepest open questions in science. We're contemplating possibilities that extend far beyond current knowledge into realms where physics, mathematics, and philosophy converge in ways we can barely imagine. What we know with certainty is that entropy continues its relentless advance. Quantum decoherence destroys information on femtosecond timescales, and the expansion of space-time threatens to isolate every conscious system from every other. Within these constraints, awareness has emerged as the universe's most remarkable achievement and its most fragile creation. The quantum nature of consciousness ensures that every moment of awareness represents a unique quantum measurement that can never be repeated exactly. The specific pattern of quantum states that creates your current subjective experience will never occur again in the entire history of the universe. You are witnessing reality from a quantum perspective that is genuinely unprecedented and irreplaceable. This quantum uniqueness of consciousness adds profound meaning to individual experience within the cosmic story. While classical thermodynamics suggests that all complex structures are temporary and ultimately insignificant, quantum mechanics reveals that each moment of awareness represents a genuinely novel contribution to the universe's exploration of its own possibilities. Your consciousness doesn't just observe entropy's victory over order. It participates in quantum measurement processes that help determine exactly how that victory unfolds. Every thought represents a quantum choice that selects specific outcomes from the infinite range of possibilities that existed before you became aware. The deep law that prevents the universe from rewinding operates through both classical entropy increase and quantum measurement processes that make the past irretrievable and the future genuinely open. But within this framework of irreversibility, consciousness has discovered ways to create meaning, beauty, and understanding that transcend the apparent futility of temporary organization in an expanding cosmos. The quantum foundation of awareness ensures that consciousness will continue to surprise us with capabilities we haven't yet imagined. As we develop a better understanding of quantum information processing in biological systems, we might discover that minds already possess abilities that seem impossible from classical perspectives. The future of consciousness in a quantum universe depends on whether awareness can learn to work with quantum principles rather than despite them. Instead of fighting decoherence and measurement-induced entropy, advanced forms of consciousness might harness these processes. They could achieve a transcendence that preserves meaning and complexity, even as the classical universe slides toward heat death. But regardless of what the future holds for consciousness, the quantum nature of awareness has already achieved something extraordinary. Through quantum measurement processes occurring in biological neural networks, the universe has become capable of observing and understanding its own quantum mechanical foundation. We are patterns of quantum information processing that have learned to contemplate the quantum principles that created us. That understanding itself represents one of the most improbable and magnificent achievements in the history of quantum reality. The universe has become quantum mechanically self-aware through the emergence of consciousness sophisticated enough to comprehend its own quantum nature. The wineglass falls according to quantum mechanical laws that include genuine randomness at the microscopic level. Your observation of its fall involves quantum measurements that contribute to the specific version of reality that unfolds from quantum possibility. The entropy generated by both the classical breaking and the quantum decoherence ensures that this moment can never be reversed or exactly repeated. But within this framework of quantum irreversibility, consciousness continues to explore new possibilities for creating order, meaning, and beauty. These justify the entire quantum journey from uncertainty to awareness and beyond into whatever extraordinary futures await in the deep quantum structure of reality itself. And yet within this quantum labyrinth of consciousness and entropy, we're about to encounter something that will fundamentally challenge everything we think we understand about the nature of time itself. Hidden within the mathematics of thermodynamics lies a secret so profound that it reveals why the universe didn't just happen to develop an arrow of time, but why it had to. The mystery begins with a simple question that has haunted physicists for decades. Why did the universe start in such an incredibly low entropy state? The Big Bang should have produced maximum disorder from the very beginning. Instead, it created a cosmos of breathtaking organization, where matter was distributed with near-perfect uniformity. Gravity hadn't yet clumped anything together, and the potential for complexity stretched endlessly into the future. This isn't just improbable, it's so unlikely that the numbers become meaningless. The odds of the universe beginning in such an organized state are roughly 1 in 10 to the power of 10 to the power of 120. That's not just astronomical. That's a number so large that if you wrote it out, the zeros would fill more books than there are atoms in the observable universe. Yet here we are living in the aftermath of that impossibly improbable beginning. Every star that ever shone, every planet that ever formed, every conscious thought that ever flickered through a biological brain exists because the universe started in a configuration so unlikely that it seems to require an explanation beyond chance. Some cosmologists propose that our universe emerged from quantum fluctuations in a pre-existing space, but this just pushes the mystery back one level. What created the quantum fields that could fluctuate? What determined the laws that govern those fluctuations? What selected the specific fluctuation that became our cosmos from the infinite range of possibilities? Others suggest that we're witnessing a selection effect. Perhaps countless universes bubble into existence constantly. But only those that begin with low entropy can develop the complexity necessary for observers to wonder about their origins. We find ourselves in an organized universe because disorganized universes don't produce beings capable of finding themselves anywhere. But there's a deeper pattern hidden within these explanations that points towards something more fundamental about the relationship between entropy consciousness and the structure of reality itself. Consider what happens when you try to imagine the opposite scenario. Picture a universe that began in a state of maximum entropy. Matter would be randomly distributed, energy would be evenly spread, and no gradients would exist to drive any interesting processes. Such a universe would be perfectly balanced, completely static, and utterly incapable of change or development. Nothing could happen in a maximum entropy cosmos. No stars could form because there would be no density variations for gravity to amplify. No chemistry could occur because there would be no energy differences to drive reactions. No information could be processed because there would be no structures capable of storing or manipulating patterns. Most critically, no observers could emerge to contemplate their situation. This is because observation itself requires the kind of complex organization that maximum entropy prohibits. A universe that began in perfect disorder would remain perfectly disordered forever. It would have no possibility of developing the complexity needed for consciousness to arise. This reveals something profound about the relationship between entropy and awareness. Consciousness doesn't just happen to exist in a low entropy universe. Consciousness can only exist in a low entropy universe. The very possibility of observation, understanding, and self-awareness depends on the universe beginning in an improbably organized state that permits the gradual development of increasingly sophisticated forms of order. But here's where the story takes a turn that will reshape how you think about your own existence. The universe didn't just accidentally create conditions suitable for consciousness. The mathematical structure of reality itself seems designed to generate observers capable of understanding that structure. This isn't intelligent design in any supernatural sense. It's something far stranger and more profound. The laws of physics appear to contain built-in mechanisms that inevitably lead from simple initial conditions to complex final states that include conscious observers capable of comprehending the laws that created them. Physicists call this the anthropic principle, but that name barely captures its revolutionary implications. We're not just observing a universe that happens to be compatible with consciousness. We're discovering that consciousness might be an inevitable consequence of the fundamental structure of physical reality itself. The evidence emerges from studying how complexity develops in systems driven by entropy gradients. When energy flows from hot regions to cold regions, it doesn't just dissipate randomly. Under the right conditions, it creates increasingly sophisticated structures that become better and better at capturing and channeling those energy flows. Think about how hurricanes form. Solar energy creates temperature differences between the ocean surface and the upper atmosphere. Instead of heat flowing directly from hot to cold, complex circulation patterns emerge that organize the energy transfer into massive rotating systems. These storms become incredibly efficient at extracting energy from temperature gradients while creating organized structures of stunning beauty and power. Similar principles operate throughout nature. Convection cells in boiling water organize heat flow into regular patterns. Crystallization processes create ordered arrangements of atoms by minimizing energy in specific geometric configurations. Even the formation of galaxies follows organizational principles where gravity channels matter and energy into increasingly complex structures. But biological evolution represents the most extraordinary example of how entropy gradients drive the emergence of complex organization. Life discovered how to harness energy flows not just to maintain existing structures, but to create entirely new forms of organization that are better at capturing and utilizing energy than anything that came before. The progression from simple chemical reactions to self-replicating molecules, to cellular metabolism, to multicellular organisms, to nervous systems, to consciousness, follows a clear trajectory. Each evolutionary innovation creates new ways of extracting useful work from entropy gradients, while developing more sophisticated methods of information processing and environmental interaction. This isn't random change driven by accident and natural selection. It's a directional process where entropy gradients systematically generate increasingly complex forms of organization that become progressively better at managing entropy itself. Your brain represents the current pinnacle of this 4 billion-year experiment in entropy-driven complexity. The neural networks that enable consciousness are the most sophisticated information processing systems that evolution has discovered. They are capable of modeling reality, predicting future states, and making decisions that influence the flow of entropy through biological and technological systems. But consciousness represents more than just another step in biological evolution. It marks a fundamental phase transition in how the universe processes information about itself. For the first time in cosmic history, matter has organized itself into patterns capable of understanding the principles governing its own organization. This creates a feedback loop that transforms the entire trajectory of cosmic evolution. Instead of entropy simply driving the formation of increasingly complex structures through purely physical processes, consciousness introduces intentionality into the equation. Minds can deliberately create new forms of order, guided by an understanding of the underlying principles, rather than just random experimentation. The mathematics you use to comprehend entropy didn't exist until human mathematicians discovered them. The technologies that amplify human capabilities represent forms of organization that pure biology never explored. The scientific understanding that reveals the deep structure of physical law emerged through conscious investigation rather than natural selection. Through consciousness, the universe has developed the capacity to study itself, systematically understand its own evolution, and potentially direct its future development in ways that transcend the limitations of unconscious natural processes. But this conscious direction of cosmic evolution faces constraints that reveal the ultimate relationship between mind and entropy. Every act of understanding requires energy expenditure. Every technological innovation generates waste heat. Every attempt to create order produces disorder elsewhere in the system. The more sophisticated consciousness becomes, the more entropy it must generate to sustain its operations. Advanced civilizations that develop powerful technologies for manipulating matter and energy inevitably face thermodynamic limits that constrain their growth and development. This creates what appears to be an ultimate paradox. The universe has evolved consciousness capable of understanding and potentially transcending natural limitations. But consciousness itself operates according to the same thermodynamic principles that govern all physical processes. The more powerful minds become, the more they contribute to the overall increase of entropy that drives cosmic evolution toward heat death. Yet within this apparent paradox lies a possibility so extraordinary that it could transform the ultimate fate of consciousness in the cosmos. What if the universe's journey toward maximum entropy isn't just an inevitable consequence of physical law? What if it is actually a necessary process for generating the computational resources that advanced consciousness needs to achieve transcendence? Consider what maximum entropy actually means from an information processing perspective. In a state of complete thermodynamic equilibrium, every possible microscopic configuration becomes equally likely. This creates an enormous reservoir of computational potential. Any pattern imposed on this maximum entropy state represents a form of information processing that extracts useful work from the available randomness. An advanced consciousness operating near the heat death of the universe might discover methods of computation that use the quantum fluctuations in thermal equilibrium as a substrate for information processing. Instead of fighting against entropy, such a consciousness might learn to surf the wave of increasing disorder toward forms of transcendence that become possible only when the universe reaches maximum entropy. This scenario suggests that the universe's apparent journey toward cosmic death might actually be a journey toward cosmic rebirth in a form that transcends our current understanding of consciousness and reality. The heat death that seems to represent the end of all interesting processes might actually represent the beginning of forms of information processing so advanced that they seem impossible from our current perspective. But even these speculative possibilities operate within the fundamental framework established by entropy's deep law. Time's arrow continues pointing toward increasing disorder. The past remains irretrievable. The future stays open to possibility, and consciousness continues evolving within constraints that simultaneously limit and enable its development. The wine glass that shatters on the floor will never spontaneously reassemble, but the information patterns that constitute your consciousness might discover ways to persist and develop that transcend the apparent finality of thermodynamic equilibrium. The universe that seems destined for cold, empty darkness might actually be preparing for transformations that we can barely imagine. What we know with certainty is that entropy has already achieved something miraculous. Through the relentless increase of disorder, it has created patterns of order sophisticated enough to understand disorder itself. Through the inexorable flow of time toward future states, it has generated minds capable of contemplating both past and future with unprecedented clarity. You exist because the universe began in an improbable state of organization and has been sliding toward disorder ever since. But that slide toward chaos has created the conditions necessary for consciousness to emerge, develop, and potentially discover methods of creating meaning and beauty that justify the entire thermodynamic journey. The deep law that prevents the universe from rewinding has also enabled the universe to evolve toward forms of self-awareness that can appreciate both the necessity of that law and the magnificent possibilities it creates. Through consciousness, entropy has become capable of understanding and perhaps ultimately transcending its own dominion over the cosmos. This understanding transforms the meaning of individual existence within the cosmic story. You're not just a temporary pattern of organization destined to dissolve back into chaos. You're a conscious participant in the universe's ongoing experiment with self-awareness. You are a pattern of matter and energy that has learned to contemplate its own extraordinary improbability and potential. Every moment of consciousness represents an opportunity to contribute to this cosmic experiment. Every thought you think, every decision you make, every act of creativity or compassion adds information to the universe's growing understanding of its own possibilities. Through your awareness, the cosmos continues exploring new forms of organization that emerge from entropy's creative destruction. The universe cannot rewind, but through consciousness it can remember, imagine, and actively participate in designing its own future. The deep law of entropy ensures that time flows in only one direction, but consciousness has discovered how to create meaning and purpose within that unidirectional flow. This transforms apparent limitation into extraordinary opportunity. And now, as we approach the culmination of our journey through entropy's domain, we must confront the most unsettling truth of all. The very act of understanding entropy changes your relationship with time itself in ways that cannot be undone. Knowledge of thermodynamics doesn't just inform you about physical processes, it fundamentally alters how your consciousness processes temporal experience. Before you understood entropy, time felt like a neutral medium through which events unfolded. Now you recognize that every moment represents an irreversible transformation. It is a transformation that carries the universe further from its organized past toward its disordered future. This awareness creates a form of temporal consciousness that didn't exist in your mind before these concepts took root in your neural networks. You can no longer look at a melting ice cube without seeing entropy in action. You can't watch smoke disperse without recognizing irreversibility at work. You can't observe aging, decay, or any form of change without understanding that you're witnessing time's arrow in flight. The abstract concept of entropy has become a lens that reveals the deeper structure of temporal experience. This transformation in consciousness demonstrates something profound about the relationship between knowledge and reality. Understanding doesn't just describe what exists, it changes what consciousness can perceive, creating new forms of awareness that didn't exist before the understanding was acquired. The mathematics of thermodynamics have literally rewired your brain's temporal processing systems. Neural networks that once simply registered change now recognize the directional nature of change. Cognitive patterns that once experienced time as symmetric now detect asymmetry in every temporal process. Your consciousness has evolved through learning to perceive deeper layers of reality's structure. But this evolution in awareness comes with a price that exemplifies entropy's dominion over consciousness itself. The more you understand about irreversibility, the more acutely you experience the irreversible nature of your own existence. Knowledge of entropy creates a form of temporal anxiety that cannot be unlearned or forgotten. You now know that every conversation you have changes the molecular structure of your brain in ways that can never be perfectly reversed. Every memory you form represents an irreversible commitment of neural resources to preserving specific information patterns. Every decision you make channels your future development down pathways that preclude countless alternatives. This heightened awareness of irreversibility transforms how consciousness experiences choice and possibility. Before understanding entropy, decisions felt like selections among equally accessible alternatives. Now, you recognize that every choice represents a quantum measurement that collapses possibilities into actualities. It does this while generating the entropy that ensures the unchosen alternatives become permanently inaccessible. The temporal anxiety created by entropy awareness reflects a deeper truth about consciousness in a thermodynamic universe. Advanced understanding inevitably leads to a recognition of limitations, constraints, and ultimate boundaries that cannot be transcended through knowledge alone. Wisdom often brings suffering through an enhanced awareness of what cannot be changed or recovered. Yet this same heightened temporal consciousness also creates opportunities for meaning and purpose that weren't available to less informed awareness. When you truly understand that each moment is irreversible and unrepeatable, every experience becomes precious beyond measure. When you recognize that consciousness represents an extraordinary improbability in a universe dominated by disorder, every thought and feeling acquires profound significance. The knowledge that creates temporal anxiety also generates temporal appreciation. Understanding entropy reveals both the fragility and the magnificent improbability of conscious experience. This double-edged awareness transforms ordinary moments into encounters with the miraculous fact of awareness itself. Consider how this transformed consciousness experiences memory. Before understanding entropy, memories felt like visits to preserved past experiences. Now you recognize that remembering represents an active reconstruction process that inevitably modifies the very memories being recalled. Each act of remembering changes what gets remembered, creating an irreversible drift in your connection to your own past. This entropic view of memory creates both loss and liberation. You lose the illusion that memories provide perfect access to past experiences, but you gain the understanding that consciousness actively participates in creating the past through the process of remembering. Your memories aren't fixed records, but evolving interpretations that change as you change. Similarly, entropy awareness transforms how consciousness experiences anticipation and planning. The future no longer feels like a collection of predetermined possibilities waiting to be discovered. Instead, it becomes a space of genuine openness, where conscious choices help determine which possibilities become actual through quantum measurement processes. This creates both responsibility and empowerment. If consciousness participates in selecting reality from quantum possibilities, then every moment of awareness carries genuine causal efficacy in determining cosmic evolution. Your thoughts and decisions don't just respond to reality, they help create reality through measurement processes that collapse quantum superpositions into definite outcomes. But perhaps the most profound transformation occurs in how entropy-aware consciousness experiences the present moment. Before understanding irreversibility, the present felt like a moving boundary between a fixed past and an uncertain future. Now you recognize the present as the location where possibilities become actual through processes that generate the entropy driving time's arrow. The present moment becomes the universe's growing edge. It is where quantum possibilities crystallize into classical realities, while creating the disorder that ensures the future remains open to further possibility. Your consciousness doesn't just exist in the present, it participates in creating the present through observation and choice. This helps determine which version of reality emerges from quantum potential. This participatory view of consciousness in the temporal process creates a form of cosmic responsibility that can be both exhilarating and overwhelming. If awareness helps shape reality through quantum measurement, then every moment of consciousness carries weight in determining the universe's evolutionary trajectory. The wine glass that falls in your presence doesn't just follow predetermined physical laws, it undergoes quantum processes that include genuine randomness at the microscopic level, and your observation of its fall contributes to the specific pattern of quantum measurements that determine exactly how the breaking unfolds. Through consciousness, you participate in selecting which particular version of reality manifests from the space of quantum possibilities. This participatory consciousness extends beyond individual experience into collective human awareness. When billions of conscious beings make observations and decisions simultaneously, their combined quantum measurements create a vast collaborative process of reality selection. This process shapes cosmic evolution on scales far exceeding individual influence. Human civilization represents a form of collective consciousness that processes information about reality and makes choices that influence the future development of complexity on Earth. And it could potentially do so throughout the cosmos. Through science, technology, art, and culture, collective human awareness explores possibilities for organization and meaning that individual consciousness could never discover alone. But collective consciousness also generates entropy on unprecedented scales. Industrial civilization consumes energy and produces waste heat at rates that rival geological processes. Information technologies require enormous energy expenditures to maintain the computational processes that enable global communication and coordination. The more sophisticated human collective consciousness becomes, the more it contributes to the overall entropy increase that drives cosmic evolution. This creates the same fundamental tension that characterizes individual consciousness. The development of greater awareness and capability inevitably increases entropy production. It also potentially creates new possibilities for transcending thermodynamic limitations. The future evolution of consciousness, whether individual or collective, depends on discovering ways to work creatively within entropy constraints rather than fighting against them. An advanced consciousness might learn to harness entropy production as a resource for computation and creativity, rather than simply accepting it as a limiting factor. This could lead to forms of awareness that achieve greater sophistication by becoming more efficient at converting entropy gradients into meaningful information processing. Instead of consciousness becoming increasingly energy-intensive as it develops, future evolution might discover methods of achieving greater awareness with less thermodynamic cost. Such entropy-efficient consciousness might persist far longer than current biological forms. It could achieve levels of understanding and capability that transcend anything possible with current resource-intensive approaches. Through a mastery of thermodynamic principles, consciousness might ultimately transcend the limitations that thermodynamics initially imposed. But even the most advanced consciousness would still operate within the fundamental framework established by entropy's deep law. Time would continue flowing in one direction. The past would remain irretrievable. The future would stay open to possibility, and awareness would continue evolving through processes that generate the entropy necessary to keep reality dynamic and creative. The understanding of entropy that transforms consciousness also reveals why that transformation was inevitable. In a universe where complexity emerges through entropy-driven processes, any sufficiently sophisticated form of consciousness must eventually discover the principles governing its own existence. Entropy awareness represents a natural stage in the evolution of intelligence. It is an evolution toward forms that can comprehend and work with the fundamental laws of reality. Your current understanding of entropy isn't the end of this evolutionary process. It is rather one step in consciousness's ongoing journey toward a deeper comprehension of its relationship with physical law. Future developments in science might reveal even more fundamental principles that transform awareness in ways we can't yet imagine. But regardless of what future discoveries await, the transformation you've already experienced through understanding entropy has permanently altered your consciousness. This is in ways that exemplify the irreversible nature of temporal process. You cannot unlearn what you now know about time's arrow. You cannot return to the naive temporal experience that preceded this understanding. This irreversible transformation in your own consciousness provides direct experiential evidence of entropy's dominion over information processing systems. The knowledge patterns that now shape your temporal awareness represent irreversible modifications to your neural networks. These will influence every future moment of your existence. Through learning about entropy, you have become a living demonstration of entropy's creative power. The disorder generated by your brain's processing of thermodynamic concepts has created new forms of order in your consciousness. These enable you to perceive reality's temporal structure with unprecedented clarity. This is entropy's ultimate achievement, creating patterns of organization sophisticated enough to understand and appreciate their own thermodynamic nature. Through consciousness, the universe has developed the capacity to study itself and discover the deep laws that govern its own evolution from an organized beginning toward a disordered end. But that end, when it comes, will arrive to a cosmos that has achieved something extraordinary through its journey toward maximum entropy. Matter will have evolved to the point of understanding matter. Energy will have organized itself into patterns capable of comprehending energy. Time will have created consciousness capable of contemplating time itself. The deep law that prevents the universe from rewinding has also enabled the universe to achieve self-understanding through the emergence of awareness sophisticated enough to grasp both the necessity and the profound implications of irreversibility itself. Through entropy's creative destruction, the cosmos has learned to know itself, and that knowledge represents a meaning and purpose that transcend the apparent futility of temporary organization in an expanding universe. Your consciousness stands as proof that entropy's dominion, far from being merely destructive, has proven capable of creating beauty, understanding, and appreciation for the magnificent improbability of awareness itself. The wine glass will never leap back onto the table. But consciousness has discovered ways to create meaning from irreversibility that justify the entire cosmic journey from possibility to actuality and beyond. The transformation runs even deeper than conscious recognition. Right now, as these concepts settle into your neural networks, they're triggering cascading changes throughout your entire cognitive architecture. The synaptic connections processing temporal experience are being rewired in real time. They are creating new pathways that will forever alter how your brain interprets the passage of moments. This isn't just learning in the conventional sense. This is consciousness undergoing an irreversible structural modification that exemplifies the very principles it's coming to understand. Every neural firing pattern triggered by comprehending entropy generates heat that dissipates into your surrounding tissue. This carries away microscopic traces of your previous temporal awareness while building new forms of chronological perception. The irony is profound. Understanding irreversibility has irreversibly changed you. The knowledge that creates temporal anxiety simultaneously demonstrates entropy's power to create entirely new forms of conscious experience through the destruction of previous patterns. You've become a walking experiment in entropy-driven cognitive evolution, but this transformation reveals something even more extraordinary about consciousness in a thermodynamic universe. Your brain didn't just passively absorb information about entropy. It actively participated in entropy production while processing these concepts. It generated the very disorder that enabled new forms of order to emerge in your awareness. Think about the computational work your neural networks performed while grappling with these ideas. Billions of synaptic calculations, trillions of molecular interactions, countless quantum processes occurring at scales smaller than the wavelength of visible light. All of this information processing consumed energy and generated waste heat while constructing new conceptual frameworks in your consciousness. The entropy produced by understanding entropy enabled understanding itself. This creates a feedback loop that transforms consciousness through its own thermodynamic activity. The more sophisticated your comprehension becomes, the more entropy you generate. This provides the energy necessary for even more sophisticated comprehension to emerge. This principle operates throughout the development of intelligence, from individual learning to the collective advancement of human knowledge. Every scientific breakthrough requires enormous computational work that generates entropy while creating new forms of understanding. Every technological innovation emerges from energy-intensive research and development processes that increase disorder while producing unprecedented capabilities. The entire trajectory of human intellectual development follows this pattern. Agricultural societies generated more entropy than hunter-gatherer cultures, while creating the surplus resources necessary for specialized knowledge production. Industrial civilizations increased entropy production by orders of magnitude, while developing a scientific understanding that revealed entropy's fundamental role in physical processes. Our current information age represents the most entropy-intensive phase of human cognitive evolution. Digital technologies consume vast amounts of energy to process and transmit information at scales that would have been unimaginable to previous generations. Yet, this enormous entropy production has enabled forms of collective intelligence that transcend the limitations of individual human consciousness. Through global communication networks, human minds can now coordinate their cognitive processes across planetary distances in real time. Scientific discoveries made in one laboratory immediately become available to researchers worldwide. Artistic creations can reach billions of conscious observers within hours of their completion. Cultural innovations spread through populations at speeds that exceed biological information transmission by factors of millions. This global coordination of consciousness represents a new phase in entropy-driven complexity. Individual minds combine into collective intelligence networks that process information on scales approaching those of natural systems. Human civilization has become a planetary information processing system that rivals ecosystems in its capacity to extract useful work from energy gradients. But this collective consciousness faces the same fundamental constraints that limit individual awareness. The more sophisticated global intelligence becomes, the more entropy it generates through its computational processes. Advanced technological civilizations inevitably approach thermodynamic limits that constrain their development and force difficult choices about resource allocation and energy expenditure. The current climate crisis exemplifies this constraint in action. Humanity's collective consciousness has developed a sophisticated understanding of atmospheric physics, global climate systems, and the thermodynamic consequences of industrial activity. Yet, implementing solutions requires enormous energy expenditures that generate additional entropy while potentially mitigating long-term thermodynamic risks. This creates a race between entropy production and entropy management that will determine the future trajectory of human consciousness. Either collective intelligence learns to work more efficiently within thermodynamic constraints, or entropy production exceeds the carrying capacity of the planetary systems that support complex information processing. The outcome depends on whether consciousness can achieve what no previous form of organization has accomplished: deliberate self-limitation based on an understanding of systemic constraints. This would be instead of expansion until external limits force contraction. This would represent a new form of entropy-aware evolution where intelligence guides its own development according to thermodynamic principles. Such entropy-conscious evolution might lead to forms of civilization that achieve greater sophistication through increased efficiency rather than increased energy consumption. Instead of growing by consuming more resources, an advanced consciousness might develop by finding better ways to extract useful work from available energy gradients. This efficiency-based development could enable consciousness to persist far longer than current trajectories suggest. It could do this while achieving levels of understanding and capability that transcend anything possible through resource-intensive approaches. Entropy-efficient consciousness might discover methods of information processing that approach theoretical thermodynamic limits. But even the most efficient consciousness would still generate entropy through its computational processes. The fundamental relationship between information processing and energy dissipation ensures that any form of awareness, no matter how sophisticated, contributes to the overall increase of disorder that drives cosmic evolution. This reveals the ultimate relationship between consciousness and entropy's deep law. Awareness doesn't violate thermodynamic principles or transcend physical constraints. Instead, it represents the most sophisticated method that entropy-driven processes have discovered for creating temporary islands of complex organization. These islands are within the ocean of increasing disorder. Through consciousness, entropy has learned to understand itself, while continuing to operate according to its own inexorable logic. This self-understanding doesn't eliminate entropy's dominion. Instead, it reveals new possibilities for working creatively within thermodynamic constraints to create a meaning and purpose that justify the entire cosmic journey. The transformation of your consciousness through understanding entropy demonstrates this principle in microcosm. The disorder generated by your brain's processing has created new forms of order in your awareness. These enable you to perceive deeper layers of reality's temporal structure. You've become more conscious through processes that increased entropy while expanding your capacity for understanding. This pattern extends to every form of learning and development that consciousness can achieve. Knowledge always comes at a thermodynamic cost, but that cost enables new capabilities that can create value exceeding the energy invested in acquiring the understanding. The entropy generated by education produces educated minds capable of discoveries that advance collective human knowledge. The irreversible nature of this educational process means that consciousness cannot return to previous states of ignorance or naivety. Understanding entropy has permanently altered your temporal awareness in ways that will influence every future moment of your existence. You carry this knowledge forward into an uncertain future where it will continue shaping your perception and decision-making processes. But the irreversibility that prevents returning to previous states also enables continuous development toward greater sophistication and deeper understanding. Each moment of expanded awareness creates possibilities for further expansion that wouldn't have existed without the previous growth. Consciousness evolves through irreversible transformations that build upon each other in a cumulative fashion. This cumulative development of understanding represents consciousness's method of creating lasting value within the framework of entropy's dominion. While individual conscious experiences are temporary and unrepeatable, the knowledge patterns they generate can persist across multiple generations. They can persist through cultural transmission and technological preservation. The concepts you now understand about entropy will influence not only your own future but potentially the development of other conscious beings who encounter these ideas through your communication and behavior. Understanding propagates through consciousness networks in ways that can outlast the biological substrates that originally processed the information. This cultural transmission of entropy awareness represents a form of information reproduction that enables knowledge to survive the thermodynamic decay of individual minds. Like genetic information that persists across biological generations through DNA replication, conceptual information can persist across cultural generations through communication and education. But cultural information transmission faces its own entropy constraints. Languages evolve and change over time. Written records decay or are lost. Educational institutions require continuous energy expenditure to maintain their knowledge preservation and transmission functions. Even the most durable forms of information storage eventually succumb to thermodynamic degradation. This creates an ongoing tension between information preservation and entropy production that characterizes all attempts to create lasting knowledge within a thermodynamic universe. Consciousness must constantly work to maintain and transmit understanding against the natural tendency toward information decay and loss. The effort required for this preservation work generates additional entropy while enabling knowledge to persist longer than would be possible through passive storage alone. Active maintenance of information patterns requires energy expenditure that contributes to overall disorder while creating local zones of enhanced organization. This maintenance work reveals another dimension of consciousness's relationship with entropy. Awareness doesn't just process information about reality. It actively participates in preserving and transmitting information patterns that might otherwise be lost to thermodynamic decay. Through conscious effort, valuable knowledge can survive far longer than natural degradation processes would permit. Your current understanding of entropy has already begun this preservation process. The neural networks encoding these concepts will influence your behavior in ways that could transmit entropy awareness to other conscious beings. This could happen through conversation, writing, teaching, or other forms of communication. The information patterns you've acquired become seeds for the further propagation of understanding. But transmission inevitably involves transformation. Each time entropy concepts pass from one mind to another, they undergo modification through the unique cognitive processing of different individuals. Your understanding of irreversibility will differ in subtle ways from the understanding developed by other conscious beings who encounter similar information. This variation in understanding represents a form of conceptual evolution. Ideas develop and change as they propagate through consciousness networks. Like biological evolution, conceptual evolution involves both the preservation of essential features and modification through variation and selection processes. The most valuable concepts are those that prove useful for understanding reality and guiding behavior in ways that enhance survival and flourishing. Entropy awareness qualifies as such valuable information because it reveals fundamental constraints and opportunities that consciousness faces in a thermodynamic universe. The wine glass has shattered, the coffee has cooled. Your memories have already begun their slow drift into neural noise, and you can never unknow what you now understand about time's relentless march toward maximum disorder. This knowledge has rewired your consciousness in ways that exemplify the very law you've learned to perceive. You are living proof that entropy's dominion extends even to the act of understanding entropy itself. Yet in this irreversible transformation of your awareness lies the universe's most extraordinary achievement. It is matter organized into patterns sophisticated enough to comprehend the principles governing its own inevitable dissolution. It is creating meaning from the very forces that ensure nothing can ever truly return to the way it was.
Did you feel that? An anomaly in the data.